Let's look at example 5.3.1. The question is, construct a logistic model for the choice between Coke and Pepsi. That we have data of Pepsi and Coke with the preference of Coke. Okay, and we are given this data, and this data actually only 18 out of 1,140 consumers, and in this case the preference is Coke. So P Coke here, okay, Coke here is the probability that Coke is chosen. 1 in this data means that if Coke is chosen, while 0 in this data if Pepsi is chosen. So that's why we represent this as P. Actually, this is our Y. Okay, remember that means that our Y here is in terms of 0 and 1. Okay, so now the next data given, that is here. Okay, this is display Pepsi. Okay, display Pepsi means that the respective store display Pepsi. Okay, 1 in data here means Pepsi is present. Okay, and 0 in this data means Pepsi is not present. And we denote this data as X2. Okay, so now the next, display Coke. Okay, display Coke, the next data given, that is the respective store display Coke. Okay, 0 here, 0 in this data means Coke is present. Okay, Coke is not present for 0. 1 here, okay, let's say 1 means that Coke is present. Okay, and this is denoted by X3, represented by X3. So now the next, that is P ratio. Okay, P ratio is the relative price of Coke to Pepsi, represented by X4. Okay, and the all data here can be obtained from Coke file. Logistic regression to the data via Excel Minor Analysis Tool Pack in Microsoft Excel. The output of the logistic regression analysis is given here. The output consists of regression statistics and the coefficient table. From the coefficient table here, we can get the estimated value for coefficient of parameters. For example, for the intercept, give and the value of the intercept, coefficient of intercept here give us the value for B1. Okay, and the coefficient for display Pepsi here give us the value for B2. Okay, and the coefficient for display Coke here give us the value for B3, while the last one here, okay, the last one, the P ratio, coefficient for P ratio give us the value for B4. Remember that in this data we have 3x, so that this is under the case of multiple logistic regression model. We have 3x. So the estimated logistic regression model P hat for this data is given by this model. Okay, we can see that all the independent variables here, this is independent variable where this is x2, x3, X3, X4 here are significant to the preference of Cook. Significance because of when we look at this part, okay, the p-value part here, okay, the p-value for all independence variable, okay, is less than alpha, and since alpha is not given here, we use standard alpha. Standard alpha is 0.05. So that since all the p-value here is less than 0.05, so that's why all the independence of variables here are significant to p hat. Now let's look at example 5.32. In this example, we want to make a prediction on p hat. Suppose that P ratio given is 1.1. Okay. P ratio means that is X4. Okay. 1.1 indicates that the price of Coke is 10% higher than the price of Pepsi. And in this case, no store displays are present. No store displays means that in this case, X2, 0. X3 is also 0. Okay. The predicted probability of Coke choice is, okay, that is P hat here, okay, is given by this value. Okay. That is by substituting all the values of X to the estimated multiple logistic regression model. Okay. Here, okay, we can get the P hat now is equals to 0.4323. That's all for chapter 5. Thank you.